having thought for a while about outputs, let's now think about inputs, how we actually read things from our microcontroller and see whether a particular pin is high or low. Well, essentially, we can read the current state from the P1 or P2 in register, and that will tell us the current state for each of the pins connected to this particular port. This register is a read-only register, so if we try and write to it, we'll just waste current. It won't actually do anything useful for us whatsoever. And what we want to do is we want to test with an AND, a bitwise AND, particular bits and see if that particular bit is a high or a low, which will indicate if there's a high voltage or a low voltage on the pin. So here's a couple of examples. If we want to test if a particular bit is a low voltage or 0, we say if 0 is equal to, and we say P1 in, and we mask it with a particular bit, for example, bit 4. And this will be true if P1.4 has a low voltage on it. And conversely, we can test if something's got a high voltage on it. We say if 0 is not equal to P1 in and bit 3, for example, that will test if there's a high on that particular pin. One little caveat that I should mention is that it can be very tempting to do what we've got to start off with there. If 1 is equal to P1 in and bit 4, and say, oh, yep, we've tested it, we're testing if that particular pin is a high. That won't work. And the reason it won't work is it's not the same as our second line there, which is if 0 is not equal to that particular value. The reason is that 1 corresponds to bit 0 and bit 0 only. We're trying to test bit 4, so we should be testing against bit 4, not against bit 0. So the safest way to actually check these all the time is to check if they're either equal to 0 or if they're not equal to 0. Anything else, and we're setting ourselves up for a bug that takes a fair time to actually discover what's going wrong. Okay, next let's talk about hardware actually connecting something to our microcontroller in the form of a button or a switch. These buttons or switches are the most common form of input to our microcontroller. Switches are generally something that we can flip to be on or off, and buttons are something that's normally, if we press it, it's on. If we don't press it, it's off. And they're spring load mechanisms. What we do though is we connect them up with a pull-up resistor, and we have in our microcontroller, we've already seen that we can have internal pull-up resistors, or we can put an external pull-up resistor on there as well. Either one's available to us. Now think about why we need pull-up resistors for a sec. When we configure our pin as an input, it's a high impedance input. And if we put a pull-up resistor on it, we make sure that this input's always actually connected to something, some sort of reliable voltage source. If we remove that pull-up resistor for a sec, if our switch is pressed or if it's closed, we're fine, we're connected to ground directly. But if it's open, what are we connected to? We've essentially connected a little antenna to our microcontroller pin, and we pick up whatever stray voltages, whatever EMP we've got there. We don't want this sort of situation, so we always want it to be connected to something. So typically what we do is we put a 10k or 20k or something in that order resistor there, and we connect it up to our VCC, our voltage source there. That way it won't be left floating, and we can guarantee what the voltage will be. We don't have to take a wild guess and hope we've got a high voltage there. So the general rule in this is we want this resistor to be large enough to not waste too much current, because think about when we press that button, we're connecting VCC to ground via our pull-up resistor. So if we had a small value resistor there, think a 10 ohm or 100 ohm or something like that, we're wasting a whole lot of current that's going to be flowing directly to ground. That's a waste, we don't want to do that. But it also needs to be small enough that it actually pulls it up. And something in the order of 10 to 50k tends to be the value that most people use, and also the value that's used internally within most microcontrollers. One other thing to consider is what's our switch going to be, what's our digital input going to be if the switch is pressed or if it's not pressed. And we can look at the circuit diagram and work this out ourselves. If the switch isn't pressed, and this is the example that we have here, the switch is open, essentially this part of the circuit isn't connected at all, and so our input is directly pulled up to VCC. That means our digital pin will display a high or a 1 in our P1 in register or our P2 in register. Likewise, if it is pressed, we essentially connected directly to ground, our pull-up's going to be very weak in comparison, and so we're going to get a low here, we're going to get a 0 here, and that's what we'll read in our P1 or P2 in register.